And welcome back to a Big Clive style teardown of a bathroom fan timer. Hope you can all see that. Alright, so this is the board. Been running in my bathroom for a long time. As you can see, it's quite simple. The board still works. It's the fan that went. After several years of use, the bearings in the motor went. And here we can see, so I pull this down a bit more, that's better. Here we can see the connectors. The neutral comes in here. This one is the switch from the lights, and this is a permanent live. So if you follow the tracks, you can see the permanent live comes in, goes up through this resistor and straight out to the fan. So the fan's always got a live on it. The other side of the fan comes back through this device here and then all the way back to the neutral. The little blue circles are the neutral points and the red points are the live. And basically you can see it's all based around this one chip, which is a CD4001, which I think is a NOR gate, quad dual input NOR gate. And we have a selection of diodes, some Zenas, some standard diodes, some capacitors and a few resistors. This big resistor is big because the mains comes in through here and then it goes through this resistor down to here. They put a bit more of a pad here because obviously this resistor does get hot. Bigger pad here, it does get hot, and I have seen some that have changed colour because of the heat. And then it comes down here through that diode and then onto these components. So if you want to trace that out yourself, feel free. And just pause the video and have a go. Building work across the road. Right, so if I take that off, and then possibly expand that out and maybe move it. Can I fit it all in? Just about. You can just about read fan live up here. And here's the circuit. Permanent live comes in, goes out to the fan. It goes through the big resistor, through the 4007, and charges this capacitor up to 15 volts. And the current limited by the 22k. That provides power to the 4001. Now, in normal operation with the lights off, R2 in this case pulls up the two inputs to 15 volts, so the output is low and this circuit doesn't do anything. Now when we switch the lights on, the switch live gets connected to the mains and of course it starts a sine wave. But because of the 470k, the highest it can go positive is 15 volts by this diode, this Zena, and the lowest it can go is 0.6 by here. And also this other Zena plays a part, so that Zena can pull it to neutral, and so can that one. So whichever one of those two has the lowest voltage, then that one will take over. But that will give you a kind of 15 volt or 15 volt pulse going going to -6 and up to 15. And -6 is probably close enough to ground on here that the chip doesn't mind it being there. And then what we get here is we get a series of 15 volts 50 hertz pulses which feed through this diode and charge the cap up. So you see the slope up here, it charges up quite quickly, and it stays charged as long as the lights are on and this is pulsing away. The capacitor stays charged. Now as soon as you turn the lights off, you remove this pulse, this gets pulled high, that goes low. D4, the 4148, is reverse biased, so this part of the circuit takes no more action in it. But we have 15 volts on the capacitor, so it's holding this input high, so this output's going to be low, these two are low, so this one's going to be high, and so it's feeding a high signal to the triac, turning it on. So that will pulse away and power the fan. Now the capacitor at 15 volts is going to discharge through this combination, and the minimum setting by the 200k and the maximum setting by the 200k and the 200k pot, which according to the manufacturing data of the fan gives a timer between 5 and 30 minutes. And so once that capacitor and resistor network have discharged, as you can see there's the slope, the lights go off here, the slope goes down, discharging. When it gets down to less than the valid, or it goes into the valid low region of this chip, of course then the output will switch high, this output will go low, and the triac will no longer fire, and so the fan stops. And then we're back to the beginning again, where there's no pulsing going on here, the capacitor just stays discharged and the fan stays off. So quite simple, very cheap to make. They've been making these circuits for a long time. If I pop up paint again, you'll see this one's copyright 2002, so this board design is already 20 years old, and doesn't seem to be anything on there that actually shows, sorry, on here, nothing there showing the date of the chip. That's about the only thing I would expect the date to be on. There's the thyristor, and there's the pot. No, not a lot to it. So I'll just take that away so we can see the circuit again. Right, if you like what you see and you want to see more, hit the subscribe button, click the bell, and I'll catch you on the next one.